All right, good morning. Welcome back to Pre-Calculus. It's been a while. So the first thing we'll do here is we'll talk to you a little bit about partial fractions. Okay, so I've got a little bit of a thing to set up here for us first. There's a lot of rules we got to memorize to help figure out how to set these things up. And I'm sorry, that's just the way it is. You have to memorize these rules to know like how this is going to work. They're not too bad though, but some of them can be a little tricky. Okay. So the idea here is like, let's say, for example, what if I had like a 3 over, say, an x minus 4, and I have a plus 2 over x plus 3, and we go ahead, how do we add these, right? We say this is 3, x minus 4, x plus 3, x plus 3, plus 2, x plus 3, and I've got x minus 4, x minus 4. And all I did was get a common denominator here, right? That's all I did. And then what we're going to do is we're going to multiply at the tops. So 3 times, why is that 3? So what we're going to do is just going to multiply this out. So we have 3x plus 9 here, 3 times x plus 3, 3x plus 9. And then on the bottom we have x minus 4. We have x plus 2. Don't multiply out the bottoms. Okay, just leave those alone. Because the next thing I'm going to ask you to do is factor the bottom. Because you have to see where the discontinuities are. You have to see where the asymptotes are. Okay, so don't multiply out the bottoms. Don't waste your time doing that. We have a 2x minus 4. Okay, and then we have x plus 3, x minus 4. Don't cancel those. We just did that. Okay, we just put it in. So we have 3x plus 9 over x minus 4, x plus 3, and then plus, and I have a 2x, right? 2x minus 8 over x minus 4, x plus 3. And then we would be given a problem. We would add those together. We get 3x and 2x would make 5x. 9 minus 8 would be plus 1 over x minus 4, x plus 3. Does it matter which order I put these in? Not really. So any order is going to work. Okay, so that's going to be fine. So the next thing we're going to do, now we're going to take and do the opposite of this. Okay, we're going to be given, okay, this thing is going to be what's given to you, and they're going to say take it apart and turn it into something that's smaller. Okay, we're going to decompose the fraction here. Okay, so like I said, there's different rules that we're going to have to memorize for each and every one of these things. It's delightful, I know. But what we're going to do is we are going to assume that we've got linear terms on the bottom here. Okay, we've got a factor of 4. We've got x minus 4, x plus 3. So we've got some linear terms on the bottom. So what we're going to do is assume that this came from some constant over x minus 4, and then some constant over x plus 3. And we know that this is equal to 5x plus 1 over, and then x minus 4, x plus 3. And then the idea here is like, well, how would I solve for a and b? What I would do, like, how do you solve a rational equation? When you solve a rational equation is to make it something that ain't a rational equation. So what we're going to do is multiply the whole equation by x minus 4, x plus 3. So when this guy goes in and visits the right-hand side here, right, all of this denominator, that all goes away. Okay, so we're going to be left with 5x plus 1 on the right-hand side. When this term here, and I'm going to visit both of the terms on the left-hand side. So we're going to have an a. The x minus 4s are going to cancel, but what are we left with? We're left with an x plus 3, and then we have a b. The x plus 3s are going to cancel, but we're going to have a b, x minus 4. And that's going to equal to whatever we had on the right side. Just multiplying through to clear the fractions because That's how you solve rational equations. You multiply, you clear the denominators to not have to work with rational equations because those are hard, right? And then what we're going to do here is we're going to say, well, this is going to be ax plus 3a, okay? And then we have bx minus 4b, and that is equal to 5x plus 1. So here's where the magic happens. And again, there's a couple of different shortcuts that we could take later. Okay, right now I'm going to do this pretty much the classical, the standard way. Not going to worry about trying to do shortcuts. Okay, there are some shortcuts we can deal with, but for now, why don't we just solve this like in a classical way, and then we can jump to the shortcut when we are comfortable with what's going on here. Okay, so hey, notice this, that okay, what we have here is I'm going to say, how about we let the x stuff over on the left-hand side equal the x stuff on the right-hand side. So we would say something like we have an a plus a b. This has to equal 5. Look at this, is called equating the coefficients. Okay, that's what we're going to do, is called equate the coefficients. And then how about the constant stuff? So how about we say something like 3a minus 4b equals 1. Okay, so all we're doing is saying, hey, the stuff that adds up, the coefficients with x's in it, has to add up to the coefficient with the x in it, and the constant stuff has to add up to the constant stuff. Okay, if there was an x squared, we would have more terms with x squareds in them, x cubes, etc. Okay, so we have more, but we're just going to say all the stuff that has x's in it has to add up to the stuff with x's in it. All the stuff that's constants has to add up to the constant. And then when I take a look at this piece, okay, once I've got my, I've done my little equating my coefficients, I can say, okay, well, a plus b is equal to 5. That's the stuff with x's in it. We might do, I used to do this. Okay, so I would know the x stuff, the a plus the b, the a plus the b was equal to 5, and then the a, 3a minus 4b was equal to the constant, C for constant. Okay, and we have a system of equations here, which happens to be the chapter we're in called systems of equations. Almost as if somebody planned it this way. Okay, so what we're going to do is we're going to just solve the systems of equations. It's two equations, two unknowns. There are about a dozen different methods that you're going to have to solve this. All I'm going to do is say, well, let's eliminate b. I'm going to multiply the first equation by 4. So we're going to have 4a plus 4b equals 4 times 5 is 20. And then on the bottom, we're going to have 3a minus 4b is equal to 1. Just going to add those two together. So we get 7a. These cancel, equals 21. A would be 3. Okay, so my a is going to be 3. Right? Since I know that a plus b is equal to 5, right, because we have a system of equations, we know that a is now 3, so we have 3 plus b is equal to 5. B must be 2. So when I go back to my original fractions, okay, when we set this up, we said, hey, we're going to have a over, okay, we're going to have a over x minus 4 here, right? That's a over x minus 4. This is back going up to, where do we set this up? Right here, plus b over x plus 3. Okay, and then we remember and say, okay, well, what do we get for a and b? A was 3, so we have 3x minus 4 plus b. B happens to be 2, x plus 3. Okay, and then when I go back up, let me take a look at what our first problem was. Like when I first started this thing, we had 3 over x minus 4, 3 over x minus 4. We have 2 over x plus 3. 2. I got the same thing. What are the odds? Okay, and that's how we set up partial fractions. We got one fraction and we decomposed it to its pieces so that we could take them back apart so we would have easier things to do. Why would I want to do this? This looks terrible. When you get to calculus, okay, you're going to have to do calculus on a problem that's going to look like this. And this is not a fun problem to do calculus on. And this is going to require a lot of different pieces to do this. But having a constant over a linear function, right? This is an easy, these are both two very easy problems to do calculus on. If I had to do calculus on this little piece, then that's a real easy problem. Okay, doing calculus on 5x plus 1 over this x minus 4 times x plus 3, that's going to be hard. Okay, and I don't want to do that. I don't want to work that hard. Okay, so the reason why we're doing this is because it takes the problems that are very difficult in calculus and turns them into problems that are easy to do in calculus. So I know that they call this pre-calculus, and there is some pre-calculus 1 in this class, but this is actually a pre-calculus 2 kind of a part of the class. Okay, if you took the trig part, that's also pre-calc 2 part of the class. So that's really the next time you're going to use this. So this is about a year in advance of where you're really going to be. Okay, but these are called partial fractions. Okay, so they take a problem that is difficult to do, and we do a little bit of algebra magic on it, and then we get two problems that are easy to do. Okay, so there are some rules. When you have linear terms, so if I have some kind of an f of x over, say x minus a, x minus b, I'll use the little ones for the constants, okay? X minus c, etc. We're going to break that into a, capital A, over x minus a plus b, x minus little b plus c, x minus little c is equal to that f of x. The way we solve that was we multiply both sides by all the denominators, okay? And we're going to get a system of 3 equations and 3 unknowns to set up over here, okay? There should probably be an x cubed, maybe an x squared over here too. Okay, because what we're going to do is we're still going to equate all the coefficients. Okay, there's going to be an x squared term. When we multiply through, there's going to be an x squared term, an x term, and a constant term. We're going to have 3 equations. Okay, so that's how we set these apart. That's how we break these apart. Okay, and most of the problem setting this up is getting this first part right. The linear equations part, it's tedious, but it's not really hard. Okay. The next thing we have is like, what if we have an f of x and we have like an ax squared plus bx plus c, and this is what's going to be called an irreducible quadratic. Okay, so an irreducible quadratic. Something like x squared plus 4 would be an irreducible quadratic. There's no factors I can pull out of this. Okay, so we're just kind of stuck with that. And the way you set this up is like, well, this is going to be bx plus c over that irreducible quadratic. Okay. When I multiply through by my denominator, okay, this is going to have an x squared term in it or an x cubed term in it at the end, and we'll be able to solve that system of equations. Okay. So that's the thing. If you have an irreducible quadratic, you need a linear term, y equals mx plus b kind of a thing on the top, and then your irreducible quadratic, ax squared plus bx plus c on the bottom. It's okay if b happens to be a 0. Okay, like I said, x squared plus 4 is an irreducible quadratic. There is no b term. That's fine. Okay, it's actually better because what you want to do is, if you have any choice, you don't want to have like a lot of extra terms here to solve a lot of extra equations. Okay, so the more terms they put in here, the more work we're going to have to do. Okay, so that's one of them. So every time, and it works the same way. Okay, if I have an irreducible cubic, okay, so if I have an f of x over some kind of an ax cubed plus bx squared plus cx plus d, and it's an irreducible cubic, Okay, you know there is a formula for like just like you have a quadratic formula, there is a cubic formula. Okay, so there is a general form for cubic solutions. I don't know what it is. I saw it at the time, but I don't. But I never had to work with it. There's a couple of special forms that reduce a little bit easier. Whereas a quadratic formula, it's messy, but it's about a line. Okay, maybe a couple of lines long. The general form for a cubic is about a page long. There's also a general form for quartic for the zeros of a quartic equation. This one went about 4 pages. Okay, it's not. I did not memorize this. It's not. Again, there are sometimes where there's like a special form you can exploit. It's really a quadratic in disguise. You can exploit that, but this is about a page, maybe 2 pages long. This is 3 or 4 pages long. Okay, there is no, and there cannot be a general form for a quintic. Okay, so general form for quintic, like an ax to the fifth plus bx to the fourth plus cx cubed plus bx plus 5, 4, 3, 2 bx plus f. There is no general form for this. Okay. When we get a little bit in higher math, you're going to find like there's two things that could represent this. You can't tell which one of them is going to be which. There's no way to tell which one's going to be the right one. So we're just kind of stuck with, well, we don't know which one it is, and it could be either one of them. So we don't have a general form for this. It's just not going to happen. So once you get to 4, which is only a couple of pages long, if you wanted to really, waste your time memorizing all of that, you could. But if you are given a quintic and they say, hey, find the general solution, don't waste your time. There isn't, they've actually proven there is no way to have a general form for a quintic or anything higher. So 4 is the best bet. Like I said, that's 4 pages long. So that's delightful. Okay, so if you want to, so going back to this, I'm sorry, I went off on a tangent. Okay, so when you have irreducible quadratic forms, we're going to represent it by a linear on top, and it's just going to go down by 1. So if I did have a cubic here, I would represent it by I would say, well, it's got to be a quadratic. Okay, so if I had some kind of an f of x over ax to the 3 plus bx squared plus cx plus d, I would start my fraction, my decomposition with one polynomial down. Okay, because what's going to happen is there's going to be another one here. We're going to multiply all that through. Okay, but there's no way I can't factor this. Okay, that's what we mean by irreducible. You can't factor this. Okay, you can't factor that. So that's where you start. And then, again, there's going to be there's going to be a couple of few, there's going to be a couple of few equations with a couple of few unknowns, and it gets to be delightful. They don't usually give you problems this big because the point is not to just do to decompose a fraction. It's to decompose a fraction so that the calculus problem you're working on is an easier thing to work on. Okay, so pretty much the biggest ones they give you in calc class is irreducible quadratics. You've got to break this apart with a linear function on top and the irreducible quadratic on the bottom. Okay, the other thing we have to worry about is repeated roots. So if I have an f of x over, say, an x minus c squared, okay, this is going to be an a over an x minus c, but I need a b over x minus c squared. For every repeated root, we're going to need another term. And the term that's on top is dependent on what we're putting on the bottom. Since the thing on the bottom is an x minus c or an ax minus b kind of a thing, only a constant. It's one down polynomial, right? This is a linear one, so we get a constant on the top. It's still linear, even though it's repeated, it's still linear on the top. That's how we set this up. If there was, if I had 2ax squared plus bx plus c, and there was a squared here, the way I would set this up is it's ax plus b over ax squared plus bx plus c plus cx plus capital D, and then we'd have ax squared plus bx plus c squared if I had repeated a term that was a irreducible quadratic. Okay, and those are pretty much the rules. Okay, so you have a constant term divided by a linear, you have a linear term divided by a quadratic, and then if they're repeated roots, you just have to repeat them. You don't change the top. The top is dependent on it. What kind of a family do we have on the bottom? It's linear. We put constants on the top. Like, well, we did it twice. You still put a constant on the top. So it's kind of like it's got to be related to the form that is on the bottom. So same thing with this. It's an irreducible quadratic. We put a linear term, ax plus b on the top. Even if we multiply this out, this is going to be a quartic, right? But the thing is, that's not going to be an irreducible. That's going to be a factor. It's going to be two quadratics multiplied together. So since this is a quadratic, we go down one. It's called a linear. Okay, so that's probably quite enough of me going on and on about this. Let's get to some examples so we can show you what's going on, and then maybe that'll help out a little bit. Okay, so I hope that helped a little bit, and we'll start some homework. So thank you.